So we're going to be continuing today. Just kind of to go over a couple things here. This is still going to be chapter 1. It's just chapter 1 was really long, so I decided to break it up. We took a test over sections 1 through 4. This is going to be section 5, which is about exponents. So we will have a test over this, but we're not going to take a test over like the stuff that we already covered. Okay, well, it's just like I'm splitting the chapter into 2 chapters essentially. Yes, sir.
Can I move over there so I can see?
Yes, absolutely. Okay, so first off, just to kind of give you guys a heads up on a couple things. When we're talking about exponents, I am going to let you guys use calculators for some things today because we're going to get to where we are getting really large numbers for some things. I still want you to do as much on paper or mentally as possible because we've got to make sure that we're understanding like what an exponent is and how they work. Otherwise, basically what starts to happen in algebra is as we start dealing with a variable, the same concepts apply. So exponents work the same way with a variable as they do with a number, but you can't type it into your calculator. So if you don't understand the process, the calculator's not going to help you any. Okay? So I'll talk to you about how I want you to enter stuff here in just a second. First thing, I want to break down what an exponent is. Okay? So an exponent is for repeated multiplication. I'm going to underline that because I think it's really important. Okay, so just to back up a second, a lot of times in math we have rules for different things, and a lot of times I think people are like, well, how do we get the rules? Why is it that way? You know, how do we know that something works a certain way? So I'm going to back up just a little bit to multiplication, okay? So you don't have to write any of this down, but 4 times 3. We know that's 12, okay? Why is it 12?
Because it can be. Because 4 times 3 is 12.
What does multiplication mean?
Multiple addition.
Yes, that's what I was looking for. Multiplication is just repeated addition, right? It means 4 plus 4 plus 4, but it doesn't make sense to write something out added a whole bunch of times, right? We can just all that is basically it's like we decided for multiplication, hey, instead of adding something 4 plus 4, if I had more of them, instead of saying 4 plus 4 plus 4 plus 4 plus 4, I could just say, hey, that's 4 times 5. Right? So multiplication is just repeated addition. That makes sense. Okay? Exponents are essentially the exact same thing, but it's repeated multiplication. So, for example, when I have something that's multiplied by itself, 4 times 4 times 4, notice here now it's multiplication instead of addition. Instead of having it written out multiplied a whole bunch of times, we can write it using exponents, and that is just 4 to the 3rd power is the way that we say that. Okay, so if it's multiplied by itself repeatedly, we can just write it using an exponent instead of having it written all out multiplied. Okay, so we've got a few different parts that we just need to talk about for vocabulary here. So this right here is an exponential expression. And the bigger number, the thing sort of at the bottom, what looks like a normal number, is what we call the base. Okay. And then the small little number up in the top, that is our exponent. So we need to make sure that we know which number is the base and which number is the exponent. You'll hear me using those two terms a lot. And the way that we read this, again, I think a lot of times people have a hard time saying it correctly, and you would read this as just x to the nth power. And in this case, the x and the n are just placeholders. Okay? So, for example, up here, we would read this 4 to the third power. Any numbers that we put in there, whatever it's there, it's going to be the base, so 4 to the whatever power. Okay? Easy enough. All right, so then here's the examples. This is what the worksheet, the homework is gonna look like. It's gonna give you something all multiplied out, real long like this, okay? And all we're gonna do here is change it to exponent form, or an exponential expression. So instead of 11 times 11, we can write that as the thing that's being multiplied, so that's going to be the thing that's multiplied is what's going to be your base. So 11. And then my exponent is how many times it gets multiplied. So what would my exponent be?
2 times.
Just 2. Yep. Okay, so we would read that 11 to the second power. But now, for the value,
122.
121.
1?
Mm-hmm.
I thought it was 122 also.
Oh, man. No, it's 121.
What?
Yeah. Always has been.
No, I thought it was 122. You got
Thought
me
wrong.
messed up if it's 121.
Hmm?
You got me messed up if it's 121. Because that's always been.
Do it up.
Also, something that I want to talk about real quick as we go on throughout the problems here. The way that I want you guys to get this value right now is I'm okay if you use calculators for some things, but I want you to actually do the multiplication right now. So I want you to not try to worry about the exponents. Don't try to type the exponents in. I want you to actually do the multiplication. So 11 to the second power is 11 times 11. That's how we got 121. Okay? All right, so next, 2 times 2 times 2 times 2 times 2 times 2 times 2. So what's my base going to be?
2.
2. And the exponent?
7.
To the 7th power. Okay? Doesn't it make sense that that's a lot easier to write and work with than having this? Like if you're in a big math problem, instead of having to write this all the time, exponents. Keep things shorter, neater. Okay. So now if I want to figure out what the value is, and real quick I want to address a common mistake that a lot of people make.
2 times 7.
2 times 7 does not work. This is not like you don't multiply this times the exponent. This is really just like a shortened version of that. So to actually figure it out, you have to do 2 times 2, which is 4, times 2 would be 8, times 2 would be 16, times 2 would be 32, times 2 would be 64, times 2 would be 128. And again, I'm okay if you use a calculator for some of these where we're getting these really, really large numbers. If they won't fit on your, basically I guess my rule is going to be, if you can't do it on your multiplication table, you can use a calculator. Okay? Yes, sir.
So it's like 7 is just like there's 7 2's there?
Yes, being multiplied.
Okay.
This means the same thing as this. When we're dealing with negatives, this is another spot with exponents we have to be really, really careful. Okay. What's my base going to be?
-5.
-5. And then my exponent would be
4.
4. Okay. When you have a negative base, put it in parentheses. Okay. That helps us to, like, if we have a bigger problem, it helps us make sure that we know this is a negative and not a minus sign, right? It's -5 to the 4th power. It's not like something minus that, okay? And it keeps everything grouped together nicely. Also, if once we start actually typing these into the calculator, if you don't use parentheses, it'll mess some stuff up, okay? So it's gonna be really, if you don't do this, I'm probably gonna take off like a half a point or something if you just did it like that. Because if you type this in your calculator, it'll actually give you a different answer. Okay? All right, now, to figure out what the actual value is, real quick, before we try to multiply anything, is my answer gonna be positive or negative?
Positive,
How do you know?
because it's all negatives.
Yes, but that isn't quite good enough because, well, think about a negative times a negative. It's like they cancel and it will always be positive. So since you could really like group those in groups of 2, that we know, hey, this is going to multiply to be a positive number. This is going to multiply to be positive.
Is it positive 250?
No, but you're close. There's a couple different, with multiplication, the order doesn't matter, so you can do a couple of different things. It's -5 times -5 would be
Negative
25.
Oh,
Yeah, that's good.
But then if I take that answer times -5, I would get -125. Okay. But if I take that times -5, now I'm going to get a positive again. And it'll actually be 625. Okay. And I'm actually fine, again, on something like that if you use a calculator. But we should get 625. What I do want us to understand, though, kind of notice how I've got an even amount of negatives there. Okay. That will always give you a positive answer. Okay. So I want you to think for a second, what if I just had -5 times -5 times -5? Would my answer be positive or negative?
Negative.
Negative. Yep, because this would be positive, but then I'd have a negative again, right? Okay. So it'll always work like that. If I have an odd amount, I'll get a negative. If I have an even amount, it'll always be positive. Yep, no matter how many there are. Okay? And so if I had -5 to the 10th power, it'd be positive. If I had -5 to the 11th power, it'd flip signs again and be negative. Does that kind of make sense? All right. Good deal. All right, now we're going to talk about fractions, and the concept stays the same. This is 1/4 times 1/4 times 1/4, so what would my base be? 1/4. And what would my exponent be?
3.
Okay? With fractions, just like negatives, I want you to put the whole fraction in parentheses. Okay? The reason I want you to do that is because if I just put 1/4 to the 3rd power, that looks an awful lot just like 1 to the 3rd over 4. Okay? Which would be different. Does that make sense? I want to make sure that that exponent goes to the entire thing. Okay? So just like a negative number, put a fraction in parentheses and then put your exponent. Okay? Now, to work this out, again, I'm okay if you use a calculator, but I want to talk about how we're going to do it. I don't want you to put 1/4 into a calculator and multiply it. Okay, I don't want you to try to type in 1/4 times a fourth times a fourth. One, it'll take you more time to do that. Look at this part right here. How do we multiply fractions? We just did this, guys.
You go straight across.
Yeah, you multiply straight across. Okay, so think about it like this.
3/4.
What's 1 times 1 times 1?
1.
Just 1. And then what's 4 times 4 times 4?
32.
4 times 4 is 16. 16 times 4 is actually going to be 64. So again, I'm fine if you use a calculator, but I don't want you to try to type in 1/4 times 1/4 times 1/4. Just use it to multiply straight across. Does that make sense? Like if you needed to type in 4 times 4 times 4, that's fine. Okay. All right. So now we're going to have some different numbers kind of mixed together. Okay. So I just group the things that are the same together. So 7 times 7 I can write as 7 to the second power. And then times 4
To the third power.
to the third power. Okay? And again, to figure out what the actual value is, just come back over here. 7 times 7 times 4 times 4 times 4. You can type that into the calculator. I would do it as 7 times 7 times 4 times 4 times 4. And if you want to expedite things, you can break it down and kind of do it by pieces. So like I know 7 times 7 is 49. I know 4 times 4 times 4 is 64 because we just did that, and that's a fact that I just get memorized. I could just type 49 times 64 into the calculator. Okay? I don't know what that is off the top of my head.
6,336.
6,336?
I got 3,136.
Uh-oh.
Oh.
We've got different answers.
Yeah, no, he's right.
So what would that be? If I took it times 100, that'd be 6,400. Half of that would be 3,200. And then I would have to subtract 64, so that would be, what, 31, 36?
Yeah.
Okay. Cool. And again, I'm fine if you use a calculator to get there. But I would rather you actually be typing in the multiplication. Don't try to shortcut it and type like the whole problem in. I don't want you to type the exponents in right now because I'm trying to reinforce like what the exponents actually are. So, is everybody all right with that?
Yeah.
Okay. So number 6 is the same sort of problem, but stuff's kind of mixed up. Okay. So what I want to kind of emphasize here is that the order does not matter. So group the things that are the same together. Okay, this is the exact same as if I had -2 times -2 times -2, right? The order of multiplication doesn't matter. So how would I write this using exponents?
-8 to the third power.
And then I can do the 8s.
And then 8 to the fourth power.
Okay, good. And then to figure out what that actually is, I just need to multiply it all together. Okay? All right, so multiply it together, and what do we get? Again, you can use a calculator for this part. I don't care to do the multiplication because like I know 8 to the 4th power is going to be a really big number.
And then what now?
Negative 32,600. 768. Again, I don't expect you to do that by hand. I don't expect you to do it mentally. You can multiply it on a calculator. With exponents, you will get really big numbers sometimes because when you're repeatedly multiplying. So if I look at just that part, 8 to the fourth, it doesn't seem so bad until you realize that's 8 times 8 times 8 times 8, and I know that just this part is 64, right? Times 8 is already going to be in the hundreds. And then I have to multiply that by 8 again, so you can see how fast it gets bigger. All right, this is the same sort of problem. Again, just group the things that are the same together. So 2/3 is going to be the base there. And what would my exponent be on it?
2.
2.
Okay. And then I've got 9. And it would also have an exponent of 2. Okay. Now, to figure this out, I'm going to multiply the fractions together first. 2/3 times 2/3. How do I do that?
Multiply right across.
Okay, so that's going to be 4/9. And then I have to take that answer, and if you know what do you know what 9 times 9 is?
81.
Okay. So does it make sense I have to take 4/9 times 81?
Yeah.
Okay. And then I can even reduce before I multiply by canceling a 9 out of both of those. And so then it's just 4 times 9, which is
36.
36 over 1, but that's just going to be 36.
Oh, wait. Oh, yeah. Never mind. I forgot you did that, didn't I?
Yep, I canceled out 9. And again, if you needed to use a calculator for this, I'm fine with that. Just don't type the entire fraction in, just use it for the multiplication. Okay. All right, so now we're going to transition a little bit. We're going to do the exact same thing, but with a variable, because again, the rules, the way it works is the same. If I've got a times 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 a, what's going to be my base?
A.
A, and then what's my exponent going to be?
9.
9.
Yeah, a to the 9th power. Isn't that much simpler to write than all of that? Okay. Now, as far as the actual value, do I know what a is?
No.
No. So do I know what a times a times a times a times a times a is? No. So we don't know. I'm just going to put a line there. We can't do that yet. It's an unknown quantity. But I can simplify it. And so a lot of times, I think this is where people start to get confused in algebra, because a lot of times directions will have something like this and they'll say simplify, and people get confused because they don't know what the number is here. But it's not asking you for the answer. It's saying take this and simplify it down to this. Does that make sense? You're trying to put it in simplest form, because this is a lot easier to work with. Okay? All right, when we get to here, notice how it's xy times xy times xy times xy times xy. Instead of putting each of them separately with their own exponent, since they're the same group multiplied by itself, I can just do xy and put parentheses, because I want to take that whole thing to the 5th power. Okay, so I'm just taking the group to the 5th power. Okay. Does anybody have any questions there? All right. Again, same thing, variable. I don't know what it is, so I can't actually find the actual value. 10. So now I've just got multiple variables, and in algebra, we typically always go in alphabetical order. That way everybody's answers is the same. okay, instead of just having a random order. So it goes Q, R, S, T. So R, and then what would my exponent be?
2.
Okay. Yep, and if you want to cross them out as you go, if that helps you stay organized, by all means, you don't have to. And then S, and then T.
3.
Is there 3 of? Yeah, there's 3. Okay. And again, with variables, I don't have to put a dot. When I write them next to each other like this, R to the second, S to the fifth, T to the third, that implies multiplication, like having a dot there. You don't have to put it, okay? It's just something that makes it easier for us. Good? All right. Number 11, same sort of thing. Just again, this is kind of common notation for algebra. Just like here we went in alphabetical order, here I always do the numbers first. Okay? So it's going to be 9 to the third power. Okay? And then K to the 6th power. Okay? Good. Okay. Can I simplify this any at all?
Maybe with the 9.
Right. I don't know what K is, so I can't do anything here, but I can do something with the 9, right?
Yeah.
Okay. So we just need to figure out what 9 to the third is. 729. So over here, I'm just simplifying it. I'm not going to get a complete answer, but I know it's going to be 729 times K to the 6th.
3,009 times 9 times 9 is 729.
Because, think about it. 9 times 9 is 81. If I take that times 9,
You get 7.
yeah, exponents can get big really quick, especially when you have a big number as a base. Okay. All right, so number 12 is going to be pretty much the same thing. I'm going to start with the number. So -7 to the 2nd power. Okay. And then I want to go in alphabetical order with my variables. So that would be M, then N. So it's going to be M
3.
to, how do you say it?
M to the third.
There you go. And then N to the second. Okay. And then yeah, I can simplify this. It would be because it's going to be negative times the negative is positive 49.
And then we have.
And that's it. All right, number 13. Again, this is one where I have a group of something times itself. So I'm just going to leave it in parentheses. P minus 2 to the third power. So I'm actually not going to do anything else here because I don't know what's inside the parentheses. So we'll just leave that blank. And then what about number 14? I'm going to have you guys walk me through that one.
3B.
What's that?
6 to the 3rd power.
6 to the 3rd power. Good, that takes care of our 6's.
And then 8 plus B to the 2nd power.
Yep, and just make sure you put that in parentheses.
And then with the 6 you get 216.
So multiply that out. That's 6 times 6 times 6, which is going to be what?
216.
166.
Oh, that's wrong.
Try again. 6 times 6 is 36,
Yeah.
and then you have to take that times 6.
B.
18 times 3. 206. Did you guys say 260?
16.
Oh, I thought you said 260. I'm sorry, you were right. And that's it. We'll leave the parentheses alone. Okay. And that's it.